In this video, we're going to take these expressions that we've learned and then we're going to apply them to obtain R30, R31, as well as R32. So these will correspond to the case when n is equal to 0, n is equal to 3, L is equal to 0, n is equal to 3, L is equal to 1, and n is equal to 3, L is equal to 2. And note that for the case when n is equal to 3, L can take on values ranging from 0 to n minus 1. So in this case, n is equal to 3, so n minus 1 is equal to 2. So there are actually 3 possible values that L can take on. So you can see that in this problem, we're going to find all 3 possible radial components. So let's start with this one, R30. So based on these formulas over here, you can see that R30, R is going to be equal to this expression, which is 1 over R, y to the power of L plus 1. In this case, L is going to be equal to 0, so we have y to the power of 1, e to the power of negative y times v of y. And then don't forget, y can be expressed in terms of r, so r divided by an. In this case, n is equal to 3, so we have 3a. So don't forget the a is the bore radius. So now we can express everything in such a way. So we have negative r divided by 3a times v of y. So these obviously they cancel out. And so you see that the only thing that remains for us to do is to find the expression for v of y. So now we're going to shift our focus to v of y. So we know that v of y is going to take on such a form. So it's going to be a sum of these, of a coefficient multiplied by a y term. And then we know that the coefficients are going to be related to each other based on this recursion formula. So what we're going to do is that we're going to take some arbitrary value, c0, and then we're going to use the recursion formula to obtain the next value. We're going to use c0 to obtain c1. So for some value of c0, c1 is going to be equal to, according to this recursion formula, 2 times j plus l plus 1. So in this case, j is equal to 0, l is equal to 0, and then plus 1, and then we have minus 3. And then in the denominator, we have j plus 1, so it's just 0 plus 1. And then we also have j plus 2, l plus 2. So both of these are 0, and then we have a 2. So 0 plus 0 plus 2. And then you can see that this term here, this is just negative 2. This is just 2, and this is just 1. So these, obviously, they cancel out. So in the end, you see that c1 is equal to negative 2c0. So now we've defined c1 in terms of c0. And now we're going to do this again. Now that we know what c1 is, we're going to use the recursion formula to derive c2. So according to the recursion formula, c2 is equal to 2 times j plus l plus 1. So now j has moved up 1 step, so now j is equal to 1, and then plus l, which is equal to 0, and then plus 1. And then we have minus 3, so this is the minus n. In the denominator, we have j plus 1, so 1 plus 1, and then j plus 2l plus 2, so 1 plus 0 plus 2. And so now you can see that this is 2. This expression here is 1 plus 1 minus 3, so this is going to be equal to negative 1. This is just 2, and then this is going to be 3. So these obviously they cancel out. So in the end you can see that c2 is equal to negative 1 over 3 c1. And we know that c1 is equal to negative 2c0. So that means we can substitute negative 2c0 to c1, so we get 2 over 3 c0. So that's what c2 is equal to in terms of c0. And now we're going to do this again. We're going to take c2, and then we're going to derive c3. And then you will see that c3 is actually going to be equal to 0, and you can see this fairly easily. You can just take this expression. If you notice the numerator, you have 2, and then once again you have j plus l plus 1, so we have 2 plus 1 plus 0. So the 0 is the l, we have the 1, and the j now is equal to 2. And then we have minus 3 because of the minus n. And then you can see that this is actually just 3 minus 3, so it's equal to 0. So we don't need to worry about what the denominator is because this is just 0 multiplied by something, so c3 is equal to 0. That means all the successive terms, c4, c5, c6, they're all equal to 0. And so that means our v of y is just going to be equal to c0 plus c1y plus c2y squared. And all the subsequent terms are all equal to 0. And now we can express everything in terms of in terms of C0, we know that C1 is equal to negative 2C0, so we have negative 2C0y, and then we have 2 over 3Z0 y squared. So I'm going to pull the C0 to the outside, so we have 1 minus 2y plus 2 over 3 y squared. So now that we've found v of y, we're ready to substitute this expression back into this expression. So remember, we're looking for R30, and now we're going to substitute this expression in. So I'm just going to pull the C0 out to the outside. We have 3a, and then we have e to the power of negative r divided by 3a, and then we have 1 minus 2y. Now I'm going to substitute this expression in because we should express everything in terms of r. And then we also have a 2 over 3 y squared. So we have a 2 over 3 r over 3a squared. And so of course we can simplify some of these terms. So this is equal to 1 minus 2r over 3a, and then squaring this, you can see that this becomes 9, and we have an extra 3, so it becomes 27 a squared 2r squared. And then this will be multiplied by the e term, so don't forget about that. So there you have it. This is your R30. And you can see that we're actually not exactly done yet. So we still don't know what C0 is. Remember that our C0 is actually just a arbitrary constant. It can take on any value. And if you want to find the complete radial component, you'll have to normalize this function. So we're going to leave the normalization part out of this question. So in this question, we're not going to normalize this function. So all we're going to do is that we're going to derive this general expression. If you're interested, you can definitely normalize this yourself, and you will find a corresponding value of C0. And so we have essentially completed what this problem has asked us to do for R30. So now we're going to move on to the next expression. Now we're going to move on to R31. So once again, we just repeat the same process that we just went through just now. So we start off with this expression. So we have 1 over r, y to the power of l plus 1. This time l is equal to 1, so n is equal to 3, l is equal to 1. So we have y squared, and then we have e to the power of negative y, and then we have vy. And then don't forget y is equal to r divided by 3a, where a is the ball radius. So now we can just substitute this directly in, and then this will be multiplied by vy. And then obviously I can just square this, so r squared, it cancels out with one of the r's at the denominator, so we get r divided by 9a squared times e to the power of negative r over 3a vy. So once again, the next task is to find vy using this recursion formula. So once again, remind ourselves that vy takes on this general form, and then starting with some arbitrary value c0, we're going to derive c1. So c1 as given by the recursion formula. In this case, now it's equal to 2 times j equal to 0, plus l, in this case l is equal to 1, and then plus 1, and then minus n is equal to 3. And in the denominator we have j plus 1, so 0 plus 1, and then we have j, so 0 plus 2l, this time l is equal to 1, so plus 2, and then we have also a plus 2, so plus 2l plus 2. And then of course we can simplify some of these terms. You have 2 minus 3, so this is just negative 1, and you have a 1 over here, and then you have a 4, so these obviously cancel out, so we have negative 1/2 c0. So now we have defined c1 in terms of c0. And then we repeat this process again for c2. So using c1, we can now derive c2, and then you will see that you can c2 will actually be equal to 0. So we have j plus l plus 1. Now j is equal to 1, so 1 plus 1 plus 1 minus 3, and obviously the numerator is equal to 0. So once again, we don't need to worry about the denominator. This is just equal to 0. So v of y terminates after c1. So v of y is just going to be equal to c0 plus c1 y, and then the rest of the terms, they're all equal to 0. And then we can now substitute in negative 1/2 c0 for c1, and then obviously we can just pull this out, and so v of y is going to be equal to something like this. And so now we're ready to substitute everything inside this expression. So we had r over 9a squared e to the power of negative r over 3a, and now we're going to substitute in c0, 1 minus r divided by 2 times 3a. So remember that the 2 comes from this 2 over here. And then of course we can just rearrange some of these terms to make it look nicer. So let's just group up the constants together and then group up the r terms together. So we have 1 minus r divided by 6a, and then we also have the e term. And so there you have it. This is r31. Once again, the only thing left to do now is to normalize this function. We're not going to normalize this function in this video. Well, we're only going to derive the general form. So this is what you're going to get for this problem. So this is r31. So now we move on to the last expression we're looking for. Now we're going to look for r32. So once again, for the third time, we just repeat the same process. So we have 1 over r, y to the power of l plus 1, l is equal to 2, so we have y to the power of 3, and then e to the power of negative r over 3a, and then times v of y, where y is equal to r divided by 3a. Well, it looks like I've already subconsciously substituted the number in, the expression in already. So we have r divided by 3a to the power of 3, e to the power of negative r over 3a, v of y, and then of course you can just expand this later on, so let's just leave that out. So let's deal with the v of y first. So in order to find v of y, once again we consider this general expression, and then we're going to start with some constant c0, and then we're going to try to obtain c1. So c1, based on the recursion formula, is equal to 2 times j plus l plus 1. In this case, our l is equal to 2, so we have our j is equal to 0, so we have 0 plus 2 plus 1, and then minus n. In this case, n is equal to 3. And so you can see that the numerator is already equal to 0. And once again, we don't need to worry about the denominator, because this whole thing is just 0 multiplied by something, so it's just equal to 0. So v of y terminates right after the first term. So v of y is very simple this time. V of y is just going to be a constant c0. And so we're essentially done here. So let's just expand, raise this to the power of 3. So we have 27a to the power of 3. And then we have these expressions. And then v of y, as we know, is just equal to one constant. So let's just group up the terms together. So we have these constants multiplied by r squared, and then multiplied by the e term. And there you have it. This is your r32. Once again, we haven't normalized this. Once you normalize this, you can find your c0. And so these are your 3 answers. So this is r31, and this is r30.